We're going to be talking about developing real-time data pipelines with Apache Kafka. So quick show of hands, how many people know what Kafka is? Awesome. How many people have worked on and done development with Kafka? How many people are running Kafka in production? All right, cool, awesome. All right, so my name's Joe Stein. Nice to meet everyone. I'm CEO of a company called Elodina. We're a big data as a service platform company. Also Apache Kafka committer and PMC member. You can catch me on LinkedIn if you want to connect. I know some folks like to have the slides during the talk, so I already tweeted my slides. So if you want to go catch those on Twitter, I can go pull the slides down and what have you. All right, so today we're going to be talking about a whole bunch of different stuff, right? I really kind of want to drill into Kafka. This is not really going to be an introduction. It's going to be, we're going to get a little deep, right? Maybe like 45,000, 35,000 feet or so. So we're going to do a little overview just for folks who maybe aren't familiar with Kafka. And then we're going to talk about topics, partitions, and segments, data durability, replication, producers and consumers, talk a little about performance and kind of how that works, a little bit about different integrations, quick start, and then we're going to talk a little about operations. And that's going to basically kind of bleed into a couple of designs that we're going to go through and look at what are the types of systems that you could actually build with Kafka and how does that work and what does it look like from an architecture perspective. So we'll talk a little bit about distributed RPC and also a reference architecture for just run-of-the-mill storage and analytics, which a lot of folks are doing nowadays. All right. All right, so Apache Kafka was first open sourced by LinkedIn in 2011. I joined the project pretty much right after it was incubated to Apache later on that year. I'm a paper fan. I don't know about other folks, but there's been a bunch of papers written about Kafka, from a technical perspective. So if that's something that interests you, go ahead and take a look. All right, so usually when folks are kind of getting into big data for the first time, right? Maybe there's some pilot project at your organization, but you go and say, all right, let me get a Hadoop cluster and let me go into some front-end facing service and let me get all the data and let me push it into Hadoop. And that's awesome and everyone's really excited and big wins and high fives and yay, now we've got all of our data in Hadoop and we're processing it. That's fantastic, right? And then someone comes along and says, okay, that project went so well, right, let's go ahead and take all of the data that we have in all of our other services, and let's push that into Hadoop so we can get the same benefit, right? So now you're at a point where you've got all your data, it's going into Hadoop, you're doing your batch analytics around it, maybe even doing some stream processing a little bit, and all is well. And then someone might come along and say, oh, this is so great. You've now integrated all of our front-end services going in Hadoop, but we have this entire real-time monitoring system that is already in place for our infrastructure, and we want data from all those services to go into our real-time monitoring system as well. So then you go in, and now you got to go and reintegrate to every single service, hook it in, move it over to the real-time monitoring system, and great. All right, that project went well, and now all of a sudden other people are getting in and say, oh, wait, we need that streaming data also, right? Let's take that streaming data, let's put it into the security system so we could do auditing and intrusion detection. Let's get into the data warehouse so we can have legacy systems be able to access it, and there are other consumer services that we want as well, right? You kind of get into this like n-squared problem of very difficult ETL. Integration. And that's really where Kafka comes in, right? Kafka is all about decoupling data pipelines, right? It looks like a messaging system, and it has messaging features, bless you, but at the end of the day, it's a distributed replicated log, and we'll talk a little bit about that. And if anyone has questions while we're going, ask. If I don't have the answer immediately, I may be talking it later. So if there's something that you're interested in, this could be interactive if you like, all right? All right, so Kafka decouples the data pipelines, right? It basically separates producers and consumers. So people who are producing data and people who are consuming data can basically go through one single source. So instead of having an n-squared problem, you basically take that integration into a problem of one, right? And it's not a messaging system, right? It is a distributed replicated log, and it's very important to understand the difference, right? And we're going to kind of talk as we go through and go about what is Kafka and how does it work. Hopefully you'll start to kind of understand what the differences are. Right, so when you're working with distributed replicated log, right, your producers can be consumers too, right? It's not just write data and then somewhere else down the line someone reads data, right? It's a very interactive process where if I'm a producer, I can be taking data, write it in XML. There could be some other consumer that's taking that XML, converting it into Avro, another consumer that's taking that Avro data, running an analysis on it. And of course, obviously, at each step, there's a producer going back into Kafka, right? You can kind of have to think of this replicated log, right? So produce data into Kafka, push an XML. Some consumer reads the XML, turns it into Avro. Another consumer reads the Avro, does an analysis on it, produces it back to data, back to Kafka. Another consumer takes that Avro, puts it back to the original XML with the response, and then the original producer could actually get back that data in the XML format. Right? And that's what we're talking about when we're talking about decoupling data pipelines. It's not just the interconnected systems, right? And this is very important, right? It's not just the interconnected systems, it's also the transformations and the analysis that goes between these different data pipelines, right? So if I can only speak, message format A, well, there's no reason for me to not just always be producing and consuming from Kafka under the, message format A structure. Other consumers and producers can handle the transformation for the downstream systems. So you don't have to worry about where to put the transformations and how do you not just connect these systems, but how do you actually get them to talk in the same format? Very powerful feature. And it does this in real time, right? So you can throw as much data as you have at Kafka, and you're going to basically still be running as fast as your network, right? So it's quite performant. All right, so let's kind of start to dive down a little bit, right? So within Kafka, we have this concept of topics. Topics is really nothing more than a logical grouping of partitions, right? And a partition is essentially, think of a partition as a log file. Well, really a directory of log files, because that's really all it is, right? The partition is a way to organize your log files, and a topic is a kind of a virtual structure that allows you to group these log files together. And when you write to a partition, you're always writing and appending to the end of the log, right? So every single write appends to the end of the log. And Kafka guarantees ordering within a partition, so every single write that a producer has is guaranteed to actually be in sequence for when you actually wrote it on a partition by partition basis. Underneath partitions, there's something called log segments. This is sort of kind of important to know depending on what you're trying to do, especially when you're configuring the system and you may look in a directory and see 30 different log files and wondering, what is that? Ultimately, the partitions get rolled in log files, and those log files are something we call segments. And so you could have 6 or 7 different log files. That is a partition. And the view of that from Kafka's perspective is from oldest to newest, and data that is old can get pruned off at the end from the log perspective, the actual file perspective. Or if you're doing something like compaction in a more ingenious kind of way. All right, so when I think about kind of the distributed replicated log of Kafka, this is kind of what's in my brain. So you kind of have this log in the middle, right? There's your partition. Everything from the partition's perspective, right? It's a stream, and that stream of data is organized by what we call an offset. And an offset is really nothing more than an incrementing number, okay? Just literally just an atomic incrementing number. So as every single piece of data comes in, the next message just essentially gets the next number. In a traditional messaging system, messages will get pushed to consumers, right? And there's maybe some transaction around that. But in Kafka, that's not how it works, right? Producers push data to Kafka, and we'll talk about that in a little bit. But consumers pull data. This is really not only where we get a lot of the benefit and performance, but we also get a lot of scalability from a pure software architecture perspective. Right? You could actually have multiple consumers reading from the same place in the stream at the same or different offsets without ever having to bump into each other from a blocking perspective or any other type of latency that's going to be caused by 2 people trying to do the same thing with the same piece of information. And consumers are fetching, right? They say, I want offset 3,762,000 and give me a megabyte above that. And Kafka just responds with the megabyte, with the offset that was the latest, and consumer can go and fetch the next piece of data. And this is kind of really just the very simple pattern. Producers write to partition, consumer reads from partition. All right, so over the years, there's been a lot of work, say over the last 3 years, there's been a lot of work put into Kafka when it comes to data durability. So when we first released 0.7 back in 2011, there was 0 data durability, right? And then we spent about a year and a half building out 0.8 and created a replication system. And over the last, slide back there. And over the last year, with 0.811 and 0.821, we've also added some more primitives that I'll talk about in a second that even increases further the data durability guarantees that Kafka provides. So this really all comes from the producer's perspective, right? So when the producer is writing data to Kafka, it basically sets what are my required acknowledgments from the brokers to make sure that this data has actually been saved, right? So you can set, no guarantee whatsoever, right? And your response is going to be in a microsecond or so because you don't even care whether there's a response or not. You can say, hey, I want to make sure I at least got to the network and the leader at least has my data. It may not have replicated or not, but I at least want to make sure it's sort of kind of there. Or you can say full-blown, I want to make sure that the data is replicated on 3 servers, and even if one of those servers is still not around for some reason, I want to guarantee that it's on 2 of them. And that concept of what we call the minimum ISR, right? So the ISR stands for in-sync replica set, right? So you have these different brokers here, right? And there's a replication factor for the partitions. So you have broker 1, broker 2, broker 3. And you could set, let's say we set a replication factor for 3 for the partition, for the topic. And then the partitions kind of flow across these 3 brokers. And if a broker dies, right, you can say, well, as long as 2 are up, I want to be able to write to them. But you want to, depending on your level of data durability requirements, what if 2 of them died, right? Well, then you kind of get into the situation where potentially for an hour, you're writing to a single rack. And if that rack dies and the other 2 come back up, well, you've potentially just lost that entire hour's worth of data, right? A lot of organizations actually have required guarantees transactionally for when you write data, like that actually has to be in 2 separate racks or 3 racks in a data center. There's different requirements that different people have. So we've kind of added and layered into Kafka to really make these type of decisions flexible for you. So when you're producing data, you really kind of know what's happening, right? Like, did this actually save? And if not, then you can go upstream and say, transaction failed, the data hasn't been stored, and you can make real good intelligent decisions behind that. And kind of the way that it works, so when replication is running, brokers are actually consumers too. All right, so there's only one difference between a broker when it's replicating as a consumer and a normal consumer. There's just an ID field. And if that ID is set to a value, then it's a broker consuming. If it's -1, then it's a consumer consuming. Pretty much everything else after that is exactly the same. And some folks have a little difficulty understanding that and why. So if there are any questions, throw them out there. All right, so let's go through the flow for a second, right? So producer decides, all right, I want full onboard data durability. Give me all brokers saving all the data all the time. All right. So producer sends message into broker 1, and broker 1 commits it to itself essentially. And then what broker 2 and broker 3 are doing is they're actually consuming the data from the leader, from broker 1. Right. So it's reading the data as fast as it can, taking the message off. So broker 2 and broker 3. Pretty much simultaneously, are now reading that message that came in, and they're also committing to their local brokers that it has this message. And when it does that, each of them are incrementing their offsets. And what the leader does, right? So what broker 1 leader does is it's talking to broker 2 and broker 3, and it's saying, hey, what offset are you at? And once that broker sees that the offset has been hit, then the broker takes the message out of what's called purgatory and makes it alive, right? This has actually now been committed. So consumers can now see the message, right? Until data, even regardless of your data durability requirements on the producer side, until the message is committed through the flow that I just went through, consumers won't see it, right? So Kafka makes sure that the data is replicated properly and committed from the leader's perspective before any consumer could see the data. And then at that time, if you set this, all acknowledgement replication, then the producer will also get a response. Hey, I've got your data. So this is kind of the flow of what it looks like from the data durability discussion perspective. So any questions before I kind of drill down a little bit further on the replication and kind of what this looks like? Yep. Yeah, so the question was, can I speak to the latency from the replication perspective, right? Yeah, I will. Once I get to the performance piece, I'll make sure I add that in. And if I forget, just raise your hand again. But yeah, I'll bring that up when we get to that. Cool. All right, so let's kind of go through a very naive use case here, right? This is just very simple just to understand concepts. All right, so again, ISR stands for the in-sync replica set, right? The in-sync replica set is basically the replicas that the cluster thinks, ultimately the controller, like the cluster thinks that they're alive, right? How far back is a broker reading in the stream, all right? And when you set up Kafka, there's like 2 little configs that you can set that will kind of tune for how far back in the stream before the system says, okay, you're sick, you're no longer a valid broker, go away, you're offline, we don't want you anymore, and send an email, page someone if you want, what have you. All right, so here we have A, B, and C. A is the leader. B and C are both replica followers. All right, so message 1 comes in, message 1 gets committed to A, gets committed to B, gets committed to C. All right, so now our offset is essentially at 1, right? All right, so now, as that was happening, as I was saying that, message 2 and 3 came in. And message 2 got committed to A, message 2 got committed to B, but it just has not yet been committed to C yet. And message 3 came in, and it has not been committed to B or C yet, right? So just think of this as like, 10 milliseconds of a snapshot of time frozen, all right? All right, so A fails, right? So some mouse went into your data center and chewed through the Ethernet cord of broker A, and that machine has just died. All right, so now there's going to be a leader election, right? So Kafka is basically going to do a leader election. It's going to say, okay, B, you are the new leader. Go do your thing. And when the leader election happens, the first thing that the leader does is say, which offset am I at, right? And it's going to see that B itself is going to see that it's actually at offset 2, right? Because it had committed that message that had come in. So it pushed in offset 2. And then it's going to wait for all the other replicas now to be at offset 2. 3 as the new follower for leader B, right? It's no longer pulling from A because A is down, right? So C is flipped over to now pulling from B, and it's going to get message 2, right? So now B pulls in message 2, and it commits its offset, and B does the final commit of the offset so that everybody can see it. Question? Yeah.
Instead to, what was it that decided that B was the leader? What if C had been deemed as the leader and said that B has a message that I don't have, or that's an incorrect message, or something to that effect?
Yep. So the question is, what deemed B to be the leader versus C, and then how would that essentially affect the messages, right? Yes? Yeah. Okay. So in Kafka, there's something called the controller, right? And the controller is a single broker that has special powers that really kind of orchestrates and runs the internal parts of the cluster, essentially. So it's purely nothing more than just leader election with Zookeeper, right? First one wins. Most likely whatever machine has the least traffic on it could potentially be the leader, right? Whoever's gonna raise its hand first and say, I'm the leader. In this case, if C did become the leader, its offset would be 1, and message 2 wouldn't be saved, essentially, right? Now, from the initial producer perspective, it died because it was connected to A, right? So that producer lost its connection. It should have upstream said, hey, 2 is never saved, right? Because it's never saved to C in the first line, right? That response never acted back. So even though message 2 is there, upstream, technically it shouldn't be, right? So you will have some data in there that upstream transactionally may never had said that it could have been saved. So it's not so much about losing data as it is you just may have a little bit extra data that upstream potentially said that it wasn't there. Yep.
So Joel, is that saying that the
Yes. The question is, so the act does not occur until all of the replication is complete. That was the question, and the answer is yes, right? And it's the leader who sees that all of the replicas have actually hit the right offset at that time, and then only then does the leader go and respond, if it can, obviously.
So in the case of 2,
yep.
no act is going to occur.
Right, no act is going to occur for M2 because it crashed while it was writing M2, right? And it never got that act back initially, even though M2 is saved there. And in different scenarios, like maybe you want that, right? Maybe you actually just want, true availability and making sure that like no matter what, you're capturing all the data that you want to capture, and it's not a transactional situation, right? Different use cases, and this is at a topic level. So you could have some topics that are extremely durable, right? And you could have some topics that are like, whatever, it's like just, metrics, so it's fine. All right, so.
But M3 is lost.
M3 is gone, right? Yeah, and with M3 being gone, I don't like to say that it's lost because technically it was never deemed guaranteed saved, right? It would be lost if it had upstream said, hey, I had this, right? And then it didn't. But there was no response ever that M3 ever made it anywhere to anyone. Yeah, exactly. Yeah, exactly. Same thing with M2. Yeah, producer would never have the acknowledgement, so no one should have the expectation that that data was ever there. So it's not that it's lost, it's more that it just wasn't saved. Yep.
So what you're saying then is like for M2, there was never an act that came back to the producer. So from the producer's perspective, M2 failed, but it's actually there. So if it tried to retry, you would have 2 equivalent of what's in M2. Is that what you're saying?
Yeah, so the question is, so if the producer got that failure, it's going to want to retry, and then when it writes it again, M2, there would actually be a duplicate. Yes, there would be a duplicate. Yep.
Just make sure it's an item on the right.
Downstream. We can talk about that too. Maybe after, but yeah. All right, so 3. So now message 4 and 5 come in. Woohoo! What's that?
All one partition, right?
Oh yes, we're still all in a single partition. Yep. All right, so now M4 and M5 fly in. And that gets written to C, and everything's good to go. And now A comes back online, right? Someone checked their pager, they put the broker on, they plugged in a new cord, whatever. A comes back online. The first thing the broker is going to do is it's going to say, all right, which offset was I actually at officially, and truncate everything below it. So now at this point, M3 doesn't even exist any longer on A, right? It's just going to truncate it completely. But then it's going to say, oh wait, I need to get back into this replica set. Let me be a follower of B. So now A is going to be a follower of B and catch 4 and 5 up. And when it does that, it can now be joined back into the ISR, essentially. And depending on what version of Kafka you're using, if you're using 0811, then at this time you'd have to actually run like a preferred leader election to move B back to A. Or if you're using 0821 and you have it turned on, that flip back from follower to leader would automatically go right back to A. All right, so let's talk a little bit about producers. So producers are very lightweight applications when it comes to its interaction with Kafka. The first thing a producer does when it talks to Kafka is it does what's called a metadata request, and it says, give me the topology. All right, so this is actually very beneficial because you don't have to worry about like service discovery or which leader should I write to or how all these like internals should be working. All of that's kind of done for you. In the producer client libraries, and we'll talk about that a little bit, and it should be. And at the wire protocol perspective, which we'll get into a little bit as well, you kind of get this entire layout of who are the leaders for which partitions, so when you write to them, you could actually go ahead and write to them intelligently. And when you create, let's say you create a topic with 3 partitions, what Kafka is going to do is basically fundamentally load balance, right? Spread the load of the partitions across the brokers. So if you have 3 partitions with replication 3, then you're basically going to have every single broker be a leader for at least one of the partitions. So whenever the producer is writing to partition 0, it's going to write to 1, and whenever it's 1, it's going to write to 2, whenever it's 3, it's going to write to 3, right? Obviously a very naive example, but if you can imagine tens of thousands of producers writing, you don't want them all just writing to one broker, right? Obviously. All right, so on the consumer side gets a little bit trickier. So there's kind of two different types of consumers. One type of consumer is where you're really low level, working intimately with the wire protocol and the offsets and the coordination of the other consumers that are running. And then the second is kind of what we call the high level consumer, which does a lot of the orchestration for you. Yep. Yeah, so the question was, if the producer's writing to more than one broker, is he always writing to the leader? The answer is yes, and same from the consumer. Everything in Kafka is about the leader. The only follower need is purely based on the brokers doing that. Producers and consumers, it's all about the leaders. Yep.
Now, a leader could be different for each partition, right?
Yeah. Yep.
That's how it spreads the load.
Yeah, that's how it spreads the load, right? The leader could be different for each partition. Correct. All right, so in the high-level consumer example, and a lot of folks have built consumers. They're awesome to build, and you should kind of build it this way. You kind of create what's called a consumer group, and a consumer group is a way to organize different consumers to either work together or to be separate. So you may have 3 consumers that really need to interact with this data and do high computations really fast, so you need 3 of them. And you want that to read off of stream topic A. But now you also want, let's say, consumer group B. Maybe it's just taking the data and backing it up to S3. So no big deal, almost no computation. Who cares if it's a little slow, right? Just as an example. So you only need one of those, right? And now you could have these 2 different groups together reading from the stream at a different time, right? So you could have multiple consumers, which could actually be processes, reading from coordinated, from the stream, right? So A1 is going to read from partition 0, A2 is going to read from partition 1, and A3 is going to read from partition 2. And this is really where partition comes in and the parallelization of the processing for that data, all right? All right, so now let's say A3 goes down. Well, what the consumers will do is basically a rebalance and kind of orchestrate themselves together and say, hey, oh my goodness, B is down. What are we going to do? So A2 can basically start reading from partition 2 because it knows A3 is down. And depending on which client library you use, because there's a lot out there, some client libraries will do a complete rebalance, meaning if you're pushing in 1 million messages per second and you have, let's say, 4,000 partitions and one partition goes down, some client libraries will actually stop all traffic and do a full rebalance. And when it's done, it'll allow the traffic in again. So, these are things that you kind of want to look at and how some client libraries work, right? Some client libraries won't do that. There's a communication layer that'll actually allow them to say, oh, all right, partition 78 is down, no big deal, give that to consumer 35. And then everyone can still kind of read and stream their data, and just the failed partition can kind of go and flip over, right? And this is all kind of depending on, who and how the library has been developed. All right, so let's talk a little bit about producer performance, and I will also roll that into the broker performance too. Yep, questions?
In the previous slide, why would it matter?
Why would what matter?
If the client, if the consumer goes down?
So the question is, why would it matter if the consumer goes down? So each consumer in a consumer group is reading from a different partition than any other consumer in that group, right? If I'm reading from partition 0, and you're reading from partition 1, and he's reading from partition 2, and he goes away, now nobody's reading from partition 2. So you and I have to be like, whoa, wait, I'll get partition 2. I'll read from that, right? You need to have someone reading from the partition, otherwise it just doesn't get processed, right? You've got data coming in that doesn't get processed. And that's why it's important to make sure that somebody's picking up that partition and reading from it, right? Yep.
If you're using Kafka native library, and if you're using simple consumer, low-level consumer,
Yep.
still rebalance, or we need to do that?
Yeah, so the simple consumer doesn't have any concept of rebalancing or anything like that, right? That's the kind of thing you have to manage yourself. And there's so many libraries and implementations that are out there. It's become a large ecosystem and a little bit difficult to navigate. But it is an important thing to understand what different, the Kafka spout and Storm was completely different than the high-level consumer does, which is completely different than how Spark works, right? All these different, it was different than how Spring is going to work, even though Spring used the high-level consumer, right? So you have all these different pieces of the ecosystem. It's really important to understand what they're doing and what your expectation is, right? All right. Any other questions on consumers? Okay. So the question is, what if you add more consumers to the consumer group? So in this case, let's say you added A4, nothing would happen because there's no partitions for it to read from. You can only have, within a consumer group, a partition being read by one and only one consumer. So here, if we added A4 in, it would be idle. However, if A3 died, A4 would potentially pick up the load and not have to double the load up on A2. Right? So I have definitely seen some people spin up, twice as many consumers so that, if they die, you've got to have them running already. There's no, ramp up time, but there would still be a rebalance, right? Yeah.
If I had 4 partitions and A3 was doing 2 different partitions, and we added 4, would it rebalance?
Yep. Yes. So the question is, if we had 4 partitions and A was reading from 2 and 3, and we added 4, would it rebalance, and then each would have 1? Yes. For the high-level consumer out of the project perspective, yeah. Again, client library specific, which we'll get into a little bit. All right, so let's talk about performance a little bit. So Jay wrote a great blog about 2 million writes per second with Kafka on some real commodity hardware. This is all the new producer that came out, I don't know, it feels like a year ago now, maybe at this point. It's a complete rewrite of the producer for a number of different reasons. And basically, you get some pretty amazing performance. So this end-to-end latency number, this is basically the waiting for acknowledgement. So the question before about what's the latency from a replication perspective, right? You're looking at about 2 milliseconds from data going into Kafka and 2 other brokers capturing it and all the communication and responses and everything else before it actually commits and people can see it. And at the same time, the producer actually gets the acknowledgement back, right? And we're talking about, lots of data going in, right? This is not just one request at, 2 milliseconds, right? This is 2 million writes. And I forget, I think the 99.9% latency, there was a 14 millisecond outlier. And I also think that there was some patches in the broker that fixed that as well, but we'll see when 09 comes out. Sorry, one more thing with the producer. So if you read the original paper of Kafka from years and years and years ago, you'll actually see the producer pittering out at about 65, 70% of network NIC saturation. With the new producer, you actually can saturate a NIC. So your producing requests are more or less network bound. And we'll talk a little bit in a second about why and how that is. All right, so let's talk about the consumer and how that works, and then a little bit more about the efficiencies that Kafka has built into it. All right, so when you're reading from Kafka, if you look at this chart, it basically says you're basically pulling data as fast as your network can go, right? No matter how much data you're pulling out of Kafka, you're going to be bound by your network, essentially. And the way that this happens is that when you look at, if you kind of conceptualize the architecture for a second, right? A producer is sending data into Kafka. And when it does that, right, the operating system page cache, everyone's familiar with the page cache or not, what the operating system page cache does is that it takes any available memory that it has and takes all the most recent writes and sticks them in memory, right? Thanks, operating system. Good job. All right. Now, what Kafka does is it uses something called Java NIO's file channel. There's a function called transfer to. And what that does is it basically does a kernel copy, right? So I think if you're really interested in this stuff, click the link. IBM wrote a whole big article about file channel and context switching and all of that. So just go read it if you're interested. This is high level. So what it does is it skips a bunch of context switches in user space, moving the data in and out of kernel space into user space and all those context switches, and it keeps it all in kernel space. And since the data is in memory, right, back to the page cache, right, the operating system page cache has that data in memory. Since that data is memory, it basically, within the kernel space, goes straight from memory right to socket, okay? And that's how we're able to achieve, basically, network level performance, right? Kind of secret magic open source sauce there to be able to stream this data. So if you have, and it's relative, right? Obviously, if you read from 3 hours ago, if you don't have enough memory to hold that broker's data in memory, you're going to go hit disk, right? Because now it's no longer in memory. Even if it's a kernel copy, you're going to go hit disk. And I've seen lots of ops folks kind of say, oh my goodness, why is this happening? It's like, oh, we just ran an analytics job. Looking at our data from a while ago, of course you're going to increase the IOPS on your machine. And sometimes folks separate clusters to work around that, and we could talk about that offline and how all that works. But so there's been a bunch written up on maximizing efficiency, and I don't think I had said this before, but the Kafka documentation is immensely detailed and very well thought through, and a good read. So I definitely say good first place to start is just go to kafka.apache.org, read the documentation. So this is just kind of one of 10 sections or whatever, some subsection within 10 sections about where the maximizing efficiency comes in, essentially. All right, any other questions on performance? All right, so client libraries. I guess first before I talk about client libraries, let's talk about the wire protocol real quick. So when Kafka communicates either between brokers or producers and consumers, it does it over TCP/IP, and it uses our own custom byte structure, right? So we're talking about byte buffer structures going back and forth over the wire. And we decided a long time ago to not use thrift or protocol buffers or any other serialization, deserialization libraries. We kind of leave that up to the higher level client so that we can be very specific around what we're trying to do without any additional overhead or inclusion of any other software applications, right? So all of this is really completely out of the box Kafka talking to itself. And the reason I bring that up is because it's a really great place to start to read and understand how and what Kafka does. Because if it doesn't go through the wire protocol, then it's an API level function. And if it does go through the wire protocol, you could actually read the wire protocol and understand what all the back and forths are actually happening. The metadata request, what data is in there, how does the structure look. So it's not just for folks who are trying to build client libraries. I actually encourage people to really read the wire protocol to kind of get a good sense around what's going on. Now, after that, go ahead and jump into a client library, right? Find a language that you use. Go check out the client libraries and give it a shot. Definitely understand what that client library does and doesn't do, because the expectations after the wire protocol, right now there's not a lot of control around that. Cloudera and Confluent had announced a while ago to start to create some more conformity around testing, and I think over the next 6 months, we'll see a little bit more of an understanding of what client libraries do and don't do, so that there's not some crazy expectation that you go download some client library and it doesn't do what the Kafka project says it should do, right? So it's something you really have to look into a little bit. And then there's one for Spring. So there's a blog post about it, some source code, some XD samples. I'm sure if you have Kafka Spring questions, Marius is here. Definitely talk to him. All right, quick start. So getting up and running with Kafka is really simple. Pop open 4 terminal windows. Click this link. Go ahead and take these commands and put them in each terminal window. And 3 seconds later, after you download it, you're basically gonna have a Kafka broker running with Zookeeper and producing and consuming data from it, very simply. So anything you type into the producer console, right? So there's a console producer that comes out of the box, so you can just type data into your terminal and it'll just get pushed into Kafka. And then a console consumer that'll just read that data off of Kafka and show it in the terminal, right? So very simple kind of, how do I get this running, first step and what have you. All right, so let's talk a little bit about operationalizing Kafka and what's involved there. Any other questions? Because kind of, as the talk's moving into different segments, if there's any other questions of something that I've brought up or saved for the end is fine too. Yep.
Where are things at for the 083 client?
You're like 6 slides ahead of me, man. I won't even repeat the question. Yeah, he asked about the 083 client. All right, so we'll get there. We'll talk a little bit about that. All right. All right, so operationalizing Kafka. So yeah, there is definitely a lot of things that you need to do when it comes to running and managing Kafka brokers. And this really comes down to managing topics and partitions and where they're sitting and where they're living, mirroring data between your clusters. What happens if now all of a sudden you have more data coming in? You have to add more partitions so that you can handle the load or better parallelize that data coming in downstream. What if you want to change the replication factor, right? Originally you thought that 2 is a good replication factor, and maybe for some topic that changed, right? So you need to have kind of a dynamic way to interact with the cluster and do things as it's operating and running, right? And it's kind of an obvious thing, but so a lot of work's been put into Kafka to allow for tooling. Over the years, and currently we're still trying to layer in more tools on top of the tools that exist now. When folks kind of go in and work with these tools over and over again, you kind of create more layers of code that we want to share in common. So there's been some work done to take the admin tools and actually make them accessible through the wire protocol, right? So instead of interacting with the tool API, the tool CLI, you could actually just talk to Kafka over the wire protocol to interact with your topics and make changes and stuff. So I want to talk a little bit about running on Mesos quick, because even if you're not going to do this in production, from a application development and testing perspective, there's really no better way to run Kafka and producers and consumers right now than on Mesos. And a lot of that comes from automating a lot of the experience that people have had running Kafka, along with automating all of the operational tasks as well. And I'll give some examples in a little bit. So just in case, this is going to be real fast, just in case people have no clue what Mesos is. So Mesos is an open source project that came out a couple years ago. It runs a whole bunch of production systems that you would all be familiar with at this point. And it really is, if you're not using Mesos, then you're more or less doing static partitioning. Even if you're running some virtual environment, at the end of the day, you're still statically partitioning those machines. Even if those machines are elastic, the machine is still holding 16 CPU and 64 gigs of RAM or whatever it is. So some human being goes in, and what they do is they'll deploy their web servers. Let's say that's the red. They'll deploy the web servers to red, and the database servers to green. And they'll use Puppet or Chef or what have you, and now all of a sudden you've got more load coming in. Oh my goodness, we need more web servers, but we don't have more machines. What do we do? So now they go and you install the web servers on the database servers, and the ops people start freaking out, like, oh my god, we should use containers. What are you doing? And then just as that's happening, the rack crashes, and now like, oh my goodness, what do we do? Like, where do we take all that load? And now you've got like 10 ops people look at each other screaming, and it's all crazy, right? And besides the craziness of having to deal with that, you're ultimately wasting resources, right? Data centers are somewhere between like 5 and 60% of just complete and total utilization, right? So if you're at the 10%, 5% utilization, that means you're wasting 90% of your resources, right? And that's the difference. That just straight up, that's the difference between like static partitioning and elasticity. And we're not talking about VMs. We're talking about CPU, RAM, disk, network, right? Fine-grained resources. And that's where Mesos comes in, right? So Mesos is basically an operating system for your data center. It takes all the computers that you have and presents it as one big supercomputer, essentially. The word super is in quotes. It depends on how much CPU and RAM you have, but I know for a fact one of the top 200 supercomputers in the world is actually a Mesos cluster, which is kind of cool. So so you don't have to worry about where the application is running. You don't have to worry about all the other things that humans worry about today. Like the computer does that for you. And as software engineers and IT folks, like we're all here to get computers to enhance what we're trying to optimize. And there's no reason that shouldn't happen in the data center. All right, and I'm a big proponent of obviously Mesosing like all the things, right? Everything should go on Mesos. Even Cloud Foundry, like everything should just run on Mesos. Yeah. All right. So let's talk about Kafka on Mesos and why am I even talking about this? So when you're running Kafka, right? There's a whole bunch of stuff that you need to do. First, you need to assign broker IDs, right? I want to launch 6 brokers, right? Well, they each need to have different IDs, and that sounds simple. Right? But if you're running in an environment where maybe you're doing things like auto scaling, well, when a machine comes down and the machine comes back in, how does it know what ID to assign the broker, right? If you have 6 brokers and broker 3 fails and the machine comes back in, how does it know to actually go ahead and assign it to broker 3? Right, now, not huge computer science problem, but still work that you have to do and work that everybody has to do to make that type of thing work. How about if you have a broker fail and you want to make sure that it actually goes and goes back to where the data is, right? Sometimes you don't want failures to actually spin up other machines. You want to wait to see what happened, right? So if a machine rebooted, let's say you're not in the cloud and you actually have real servers and the machine just restarted, right? You don't want some system to just go say, oh, let me start another broker somewhere. Because if you have 20 terabytes of data sitting, it's going to take a long time to replicate over your network. No matter how fast your network is going to be, it's going to be 20 terabytes of data over your network, and it's going to take time, right? So you want to have some intelligence behind these scaling optimizations, and you want to do it in a way that it knows how Kafka works, right? You also want to do configuration changes, right? Everything in Kafka is configurable. I mean, there's so many bells and whistles and buttons and levers that you can really do anything, and it's all based on property files. And when you manage that, right, now you got to get Chef and Puppet, and now you get it all to work together, and then you got to get rolling restarts to working, and like, oh my God, how does that work, right? So there's a lot of effort that goes into that. Scaling clusters up and down, right? Like, how do I add more brokers? How do I even create a topic and have the partitions go on different racks or different AZs, right? So like when you create those partitions, you want to make sure that the brokers that they're on, they're not all in the same rack, right? If you have 20 brokers and 4 racks, 5 per rack, and you create a topic with replication 3, you don't want all 3, you don't want all the partitions to be on rack 1, right? So yeah, good. Yeah, so the question is how distributed is this? So the answer is it's as distributed as you have the ability to distribute Zookeeper, right? So long story short, really it's a per data center type of a cluster, right? It's not for the faint of heart to go ahead and make Zookeeper run worldwide. And if that's something that you want to do and you're interested in, then like totally Google Camille Fournier's post on doing multi-DC distributed Zookeeper, right? It's really kind of the best place to start with that type of stuff. However, Kafka has lots of tools that have been built to make it so that you could have a Kafka cluster running in one data center. And then there's a couple of different mirror makers out there. We call them mirror makers. There's one in the Apache project. Our company built one. And basically what they do is they just mirror and replicate the data from one cluster to another. So yeah, so you can have the geographic boundaries with multiple clusters. The one thing that you wouldn't get would be that data durability guarantee that it actually wrote it to another place. If you want to do something like that, then you should use Cassandra, and you should have the consumer do some ping back to the producer, which we'll talk about a little bit in the designs. You could have the consumers actually ping back to the producer that it was written to Cassandra. So you can do a multi-DC quorum write in Cassandra, and then the consumer can tell the producer that that happened. So you can actually achieve a global distribution from your Kafka data, but there's some more software engineering that you kind of have to get in there. I mean, it's like straight up, like pull the goggles down, light the blowtorch, but it can be done. And people do it, and it works great. All right. And then, like I said, smart partition assignment, right? Like, where are these partitions actually being created? It's an open source project, so if you want to go check it out, it's github.com/mesa/Kafka. So what the scheduler does is basically everything that I just said and more, right? The scheduler is one intelligent piece of software running on the cluster that's watching everything that's happening with the brokers and understanding what should happen next. So you have one single piece of code that's actually automating everything. What are the broker IDs? Which brokers are going where, which partitions are going where, right? You actually have software that's making the decisions instead of having to open up a Jira ticket and have a DevOps person go and use Puppet and do all this other crazy stuff, right? Like all of that is completely automated nowadays, if you want to use it, of course. And then there's a REST API and CLI, which I'll talk about real quick. So everything we do from the REST API perspective, we also make available in the CLI and vice versa, so that either a human or an application can work on this. So you can pretty much add, update, remove brokers. You can create topics. You can start brokers. You can stop brokers. You could rebalance the partitions within the cluster. I mean, pretty much anything that you could think of that you can do with Kafka, you can basically do through the REST API programmatically in an automated way, or from a command line as an operator, essentially, right? I mean, everything, right? Topic creation, updates of configs, rolling restarts, the whole 9 yards. And it's really simple. Like, you could launch 20 brokers in seconds. So you can go into the Vagrant folder of the project and Vagrant up and run this, and then boom, you've got 20 brokers running in a couple seconds. All right, so let's talk about 0.9. Any questions about any of that, or? Cool. All right, so 0.8.3 is not coming out. All right, it was decided that 0.8.3 will be renamed 0.9. So it's coming out, but just under, you know, the more recent name, which makes a lot of sense because there's actually a lot of features. There's like, I looked, there's like 300 something resolved tickets, and there's still 23 blockers open on 0.9. So there's a whole lot that's been done on trunk since the 0.8.2.1 release. And then there's still a whole bunch of other stuff. But the two things that I really wanted to call out more than anything else was the new consumer and the security changes as well. So first, quick on the new consumer. So the new consumer the consumer has been completely rewritten, right? So just like the producer was rewritten, the consumer has now been rewritten as well. And the consumer had a much larger rewrite than the producer. So on the producer side, when you went from old producer to new producer, you basically went from a keyed message to producer record, and then just bound to a new library, and maybe one other change, and that was it, right? Real simple plug and play. You got rid of the Scala dependency, and everything was a Java dependency, and really easy, kind of good to go. The new consumer wasn't just written in Java; it is completely redesigned, right, from the ground up, taking every single issue that people have had. How do I manage my own offset? All of the things that people have been trying to do with Kafka from the consumer perspective, and either, maybe not doing the best job that could have been done and still putting it out there, or just not being able to work with it at the fine-grained way and said, no, I just have to go right to the wire protocol and just build everything from the ground up completely how I want it. And what the new consumer is really geared towards doing is people not having to work with the wire protocol if they don't need to, right? But still give them enough power to be able to run and build all the features that they need to build with a really good API. So if you're interested in this kind of stuff, or you're a user of Kafka, definitely go check out the consumer redesign and understand it. You can go play with it off of trunk. There's still some more work that needs to be done. There's no more dependency on Zookeeper from the consumer's perspective. We are handling that now on the broker side, the same way that Kafka has a controller for the brokers, where the controller is deciding what's happening with the different brokers. There's now also a coordinator, right? So the coordinator is actually handling the partition assignment and the rebalancing and all of these other intermediaries. There's quite a bit in there to take a look at. The second is security. Yep, go ahead.
Before you define, what Kafka versions is it compatible with?
0.9.
The only,
Yeah, the new consumer will only work in 0.9. Yeah. Okay. Yep. Yeah, so the question is, how about the old consumer API? Will that be deprecated and supported? Yeah, so the idea is to deprecate that, right? Whether it continues to be supported, I don't think that will happen inside the Apache project. But if enough folks are still using it, it's not too hard to work on that. Really, the issue comes is that we decided 9 months ago or so to not put anything in the old consumers unless it was like super critically broken, right? And we did that because there's so much functionality in the new consumer, except for the, how do I take my code and get it to work with the new stuff? Besides that, right, which obviously is a lot for people, I get it. It really is the path that we want people to be on. That high-level consumer is old, right?
let's talk about the simple consumer.
Oh yeah, the simple consumer. Yeah, so I think on the simple consumer side, it's the same story. Honestly, it's still the same story. Yeah. All right. Yeah.
How painful or smooth would an upgrade from point 8 to point 9?
S-
Yes.
So the question is, how smooth would point 8 to point 9 be? And then is that from brokers or all the other?
Whole ecosystem.
Okay, whole ecosystem. Yeah. So when we developed 0.8, we specifically made that the last breaking change we really ever wanted to do, and we actually created something called the Kafka improvement process, which I actually glossed over. So thanks for reminding me. I'm answering your question, I promise. And with the Kafka improvement processes, if anyone's like familiar with like pip or whatever, it's kind of modeled after the same thing. We call them KIPs. And what it basically is a way for either contributors and committers of the project or even people outside the project to really document and explain what is happening with these changes. So if there are things like a breaking change, you understand like what to do with it. And everyone else also understands if we even want to allow something like that to begin with, right? These Kafka improvement processes, these are proposals, right? And we've been very strict and focused to have as few, if no, breaking changes ever when it comes to this stuff. So the 0809 upgrade, at this point, should really be in place, right? You should stop a broker, start the broker, and it starts up, essentially, right? And even if the wire protocol changes, like the wire protocol is versioned, so you can still have different parts of the systems talking at different versions at different times. Once all those new brokers are up, then now you can go ahead and roll out your new consumers and everything else. So it really should just be a in-place upgrade, stop, start, run it, and kind of good to go. And that may not, honestly, just because we need to be honest with ourselves here, that may not happen to 0.9.0.1, right? That could be what happens in the patch release after a lot of different people try to upgrade and hit different scenarios. But the LinkedIn team and the Confluent team and a lot of other folks who run Kafka off of trunk, they go through all this obviously, right? So hopefully as much can be catched as possible. But yeah, you want to test it out too, right, in your own environments. But yeah, it should be in place quick. Yep, no headaches. All right, so security. Yeah. So Kafka has never had any security whatsoever in any way, shape, or form, not even close. And anyone who's ever used Kafka knows that if you're talking to the network people and you're trying to put credit card data in, you're going to have potentially some issues. So what we did is we looked at the entire pie in the sky, how would security in Kafka look years from now? And we kind of coordinated and talked about all the different pieces of what we wanted in there. And now, on trunk, you have SSL, SASL authorization, right? Kerberos, you can actually do some pretty cool things now with Kafka from a security perspective. Producers and brokers and brokers and brokers and consumers and brokers, not only can they be encrypted, they can be authenticated and authorized, and you can have it run in the same Kerberos environment that you have with everything else, right? The story around security from a Kafka perspective has really, it's not even that it is, I can't say that it got better because it didn't exist, right? It's not like the story was bad, it just didn't have one, right? But now the story is actually a good story out of the gate. And I think for anyone who's worked with the Kafka community, one thing is that, yeah, it may take a little bit of time for releases to get out, but it's really well thought through. And the code is really well written and worked on diligently. And a lot of folks have contributed to this, right? This is a combined effort between 5 or 6 different organizations. Hortonworks, Cloudera, everyone's kind of gotten together to figure out how do we make Kafka work the same way that our Hadoop Kerberos works, right? And how do we test it out to make sure that that never breaks? All of that work came from that effort essentially. And there's more, right? There's always more to be done, and it's an open source project, so if people are interested in contributing, awesome. Always looking for more folks. And then there's Jira, right? So everything's in Jira, just like everyone else. And if you're interested to see where we are with the 0.9 release, it's really hard to say. Everyone's like, oh, when is it going to get it released? All right, when you click on that Jira link and there are no blockers, that's when it's going to get released. You know, and unfortunately, that's the best answer that I could honestly give. If you want me to like look at my crystal ball or like shake my magic 8-ball and like look up and see, it's like, when is it going to get it released? I don't know. You know, like maybe sometime in October, right? Maybe another 3-4 weeks to knock out some of the last consumer issues that are there, or some of the other changes that maybe need to go in. But you know, it's hard. It's like herding cats sometimes in an open source project. But things are moving along, right? There's a good pace that's now coming out. So I'm excited soon to, and you can run it off of trunk if you want. Like if you really need security off of Kafka, go pull trunk and start using it. Yeah, anything else on Kafka 09? Anything else? Yep.
Whether a 1.0.
Huh?
Is there ever going to be a 1.0?
Yeah, so we talked about 1.0 a long time ago, and what are all the different things that need to be in there? So you can go and like search the mailing lists and look into that kind of stuff. We kind of, when we originally planned 0.9, it was really all around the new consumer, and now that that's there is kind of why we changed the name from 0.83 to 0.9. And when I say we, like this is a community discussion, right? It's an open source project, like no single person makes the decision, it's complete meritocracy, right? It's an Apache project. Yeah, I mean, whether 0.10 comes out before 1.0, maybe, right? Like definitely could see a 0.10 release coming out for a 1.0 release, because there's still so much other things that you want to have within the stack. If people have been following the KIPs and any of the discussions, if you haven't, make sure you're sitting down. Like Kafka's going to get really crazy soon, because there's going to be so many features that you used to have in other systems that are actually now going to be built into Kafka, right? So to call out 3, and this is not in 0.9, so this is like post 0.9, right? So one is a system called Copycat, and there's another one that's a processing system, and then a third that's like a transformation system. And basically that's going to allow you to do a couple things. So one, you're basically be able to take a Kafka broker and then have what's called a connector. And the connector is going to allow you to implement whatever connectors are available. So let's say there's a JDBC connector for Kafka. Then you basically take the JDBC connector from Kafka, and it will just automatically start pushing data into the Kafka broker from your database, right? And then same on the other side, source and sync, right? So on the source side, anything that's in the Kafka broker, you could just have automatically written to S3 if there's a connector. And prior to this kind of connector paradigm, there's just a lot of work in the producers and consumers that people had to write over and over and over the exact same code. So if you're really interested in that, I think Neha is giving a talk at Strata in like a week or 2 about it. Definitely try to attend that or watch it or whatever, or just go on the mailing list and read about Copycat and some of the other features that are in there. Also transformations and processors. So, I mean, it's going to get streaming, right? You're basically be able to do joins. You're going to be able to do transformations, right? You kind of think of like, what if, what if someone sat down and said like, what would it look like if we took Samza and pushed it into Kafka, right? So you can go follow all those threads in the mailing list, right? This is all public information. So hopefully it's not too shocking to folks. And personally, I think it's really exciting, right? To basically be able to get kind of Kafka out of the box running, and then all of a sudden it's just reading and writing from the different systems that I need to with like 0 development. Fantastic, high five, like more of that. All right, any other questions about that? Kind of want to talk a little about, because we got about 20 minutes or so. Kind of want to talk a little bit more about different designs of kind of how an architecture would look like if you're trying to use Kafka and what have you. Yep. The question was, am I going to elaborate about the persistence of Kafka? In what way? That I haven't already done, sorry. Like what other information? No, but if you have a specific question after the architectural patterns, just bring it up again, and then we could talk about it. And if that's not enough, ask me after or something, okay? But yeah, not gonna get into that. We're totally now on pure architecture, what you do once you've gotten through all the other slides, right? And kind of now we're looking at this from a system perspective. All right, so a lot of people have been trying to do distributed RPC for a while, right? I think when Storm came out, everyone got really excited. It's like, ooh, we can do distributed RPC, and everyone tried it. It was like, like maybe not. So it's completely possible, though, to build a distributed RPC system with Kafka. We built a couple of them in different languages and different systems, and it's not entirely challenging to do it, and kind of just talk through One, why you would want to do something like that, and two, what are the pieces that would actually make this work? So first, the reason you would want to do something like this, right? Why would I want to push data into Kafka, and then after that data has been pushed in, take that response and send it to someone else, right? Kafka's not a queue. At least that's what some people say, and they think that. And so what happens is, like, let's say you have a situation where you have an email, and you're processing emails, or you're processing instant messages, or whatever it is. You're processing some data, and you want to do like a compliance check on it, right? You actually want to see if this data is valid. And then let's say you also want to do a security check, and then you also want to have it go through your machine learning algorithm to decide, whether or not you want to, tell that user who is clicking something that they should buy more of something else, whatever it is, right? You have these kind of lots of different things that you want to happen along the data pipeline. Right? And then once all of those different things have done, right, you actually then want to have a response geared to what that original request was for. And that's what we're talking about here, right? So let's say a message comes in to the producer, so one. Producer writes that to the Kafka cluster. And then you have a consumer that reads that from the Kafka cluster, right? So at this point, you're about 2 plus a teeny bit milliseconds between the producer writing and the consumer reading, right? So just someone keep track, right? 2 milliseconds. Now you want to send that through some type of complex event processing system, right? Maybe it's Storm, maybe it's Spark, if you're not worried about the micro-batching latency. Maybe you've just built your own, which a lot of folks do. You want to have that data go through all the different systems that are important to you, right? Maybe you have it go through the machine learning one, and then concurrently, right, you also want to have it go through some security validation, right? Now, back to the first one. Now when it's going through the machine learning part of your system, you need to parallelize that potentially. You may actually need to take that message and break it into 6 different parts and run it on a bunch of different machines in order to get the data back in one time, right? To get like what information you're trying to derive from it. And then concurrently at the same time, you have this other system too that's trying to do a security check, right? So now here you've got 2 systems kind of happening. One is parallelized, and concurrently you have another one that's just doing a simple check. And then when they're both done, they kind of join back in at the end. And then, it's 4. You're kind of following along here. And that time is going to be whatever it takes for you to do whatever it is you want to do, right? If it takes you 8 minutes to do a security validation, you've just added 8 minutes to the processing. Get a new security system, right? if you're right, so you're at this point, you're bottlenecked for what processing you've done. And I see a lot of folks, they'll do processing within 7 milliseconds, 15 milliseconds, and they're doing some really difficult things at very fast speeds with a lot of data. So you can get to about what would be a total 7 to 15 milliseconds at the end of this piece, even just using something like Storm, right? If you take Storm and put this in there, even something like that system will still give you only another 10 milliseconds or so of what this processing looks like. And Storm's great for that, just from the task parallelization perspective. But again, you could just roll this yourself too. All right, so now that that's been completed, right, now you could have one single piece of code that looks at and says, hey, did the security check pass? Well, if it didn't, then your response is going to be different than if it did, right? Now, in either case, what happens at this point is you make an RPC call right back to the original producer that sent it. So imagine you have a bank of 1,000 machines, and every machine is a producer for this discussion. And the message came into server 63. Well, that information of where the message originated, you bake that into either the key or the message of the data that you're writing to Kafka. And when the last part of the RPC system gets that data, it knows where to basically write back to and can do an RPC call right back into the original producer. And you could do that in all sorts of different languages, in all sorts of different ways. And then the producer gets that data, and it's holding a future or blocking or however it's been implemented. It gets the response, and then returns the response to the original sender, right? And if you think about that, it's kind of cool. Like it's pure distributed RPC, right? You've got a message come in. It now goes and runs on dozens of different machines to basically calculate what that response should be. And then when the response is done, the information goes right back to the originator, and they've got their message back. So yeah, this can't work for high frequency trading, straight up. It can't. But For almost every other problem above that, you're going to be within a 25 millisecond window tops, if you're really good at the processing piece, obviously. And with 25 milliseconds, that's really good. I mean, you can put that into a system with some network latency and still do quite a lot. But of course, every use case is relative, so something to be thought through. Cool. Any questions about kind of like distributed RPC or anything else in the distributed RPC side before we kind of talk about a different reference architecture?
How is that usually communicated? Who to send that response back to?
Yeah, so it depends. We've done it two different ways. So one way we've actually embedded it in the key. So when the producer writes the data to Kafka, it puts in the key. So when you write to Kafka, it's a tuple, it's a key value, right? The value is the message. The key does a couple things. It tells you which partition it should be on, right? If you're doing compaction, it'll do some compaction stuff. But it's also a way to hold some metadata, right? And that key could actually be an object. It's binary data. So you could actually create a structure that you can kind of store this data inside the key. Or you can store it in the message, right? Flip a coin. Don't be too pedantic about it. The nice thing about being a key is, if you're not using something like Avro, then you're not kind of muddled in with other messages of what people are reading and throw an exception or whatever like that. But you just want to put that in there. It could just be a URL, nothing more, right? It could be a REST endpoint that you have a persistent connection to. You could use Akka remoting. I mean, there's all sorts of, probably have a talk for an hour just about all the different ways that you can do RPC at this point. Use thrift, don't use thrift, whatever it is, right? So as long as you know which machine you're connecting to, just sprinkle that in before you write it. Server 63, port 75, whatever it is, right? And then when you get the RPC call, you know exactly where to go and hit, and you send the data there. Yep.
Just wanted to add that use something like integration Kafka, for example, there's a concept of the feature can actually work over the Kafka channel adapters. It makes that kind of work. So find it together and do this type of stuff. So essentially just abstracting the fact that it goes down.
Cool. I don't know if I could repeat all that, but it sounded, just to repeat it. So it sounds like in the Spring integration, there's a connector that has a gateway that allows you to do this. It comes that. Okay, cool. Mm-hmm. So the question is, in number 3, how does one consumer know to pull from that? Right? Yeah, good question. Good question. So the question is basically around one consumer versus multiple consumers, and how is that read, and how does that work, right? Yeah. So the whole idea here is that this would be one consumer group, right? You can have other people reading from the stream at the same time. The complexity then becomes a lot more difficult to have it join back in later, right? It's better to kind of just have one consumer group reading all the data in, and then within whatever type of direct acyclic graph system that you're using, let it handle that kind of stream coordination. If you had another system that was reading this, you're going to start sending stuff back to the producer at the same time. Now you have to bake the logic into the producer to go and coordinate. It's like, oh, I got this response, I got that response, and like, oh my goodness, what am I going to do with that, right? You want to keep all of that complexity like in 4, essentially, right? So you have all the data coming into this one architectural part of the system and the subsystems within it, because when all of that is done, it goes to that one kind of RPC endpoint, right? If you were, and not to keep bringing up Storm, but like I'm not doing that to promote it, just a good example, like you could have a bolt so that it waits for all the pieces of messages that has to come in, right? Like so many systems have been built to do that, and you want to let them do that for you. And then once it's done, it goes ahead and pushes back in. Now, while that's running, there's nothing stopping other consumers reading at the same time, essentially, to do other things. And there may be some situations where you might have to have multiple consumers reading and then aggregating some result and then pushing it back. But that would be, I think, a little unnecessarily complex. But so I'm not sure if that completely answers your question or not, a little bit. Right, any other questions before we kind of switch over the reference architecture? And we should still have like 5-10 minutes for questions afterwards. All right, cool. All right, so yeah, so this is like a reference architecture I use pretty often with folks. Kind of the idea here is like we've got lots of data in lots of different systems, and ultimately what we want to do is store, analyze, and search this data. Yay, awesome, cool. So at step 1, right, the idea here is that you want to do a little transformation up front at the producer side as possible. This is not just a technical thing, this is also politics and religion within organizations, right? You've got different groups responsible for different pieces of data. You should just get them to get the data in Kafka. Don't worry about what the format is, what transformations have to happen. Don't worry about any of that, right? Quick, simple, like you have an AS400, no problem. Just get the data into Kafka. Don't worry about the form, nothing. Binary data. Producer, into Kafka. After that, you worry about everything else that we just talked about. You worry about your transformations, right? How do I take this XML data and turn it into a protocol buffer, right? How do I turn this JSON data into some proprietary format that we've been using for years that nobody knows about, right? All of that should be handled within your transformation tier, which is 2.3. And there's lots of different systems that have been built that could allow you to do this, that work with Kafka just from a streaming perspective, or you could just write your own, right? Just write your own consumers that read the data, make whatever transformation it needs to make, and then produce it back into Kafka. And that's kind of where this topic S comes in, right? The quote unquote standard topic, right? You've kind of like normalized your data set now, right? Maybe you have 750 different XML versions that you have to support, but you don't want to have to do an analysis on every single different version, right? You want to create a normalization of your entire data set, right? And this allows you to do that. So when you're doing your analysis, you're doing it on basically one structure, potentially Avro. So now at 5 and 7, we're kind of Lambda architecturing here a little bit. So in 5, we're taking the data and basically raw, just no calculations, no nothing. You just write the data somewhere, whether it's Cassandra or Hadoop or wherever you're storing your data. Just write it, no transformation, stream write. And then in 7.8, here's where you have a system that's actually maybe trying to do some calculations, right? Maybe it's reading the data that's coming in, and it's trying to do some real-time analysis, right? If this was log and metric data, you could have some machine learning trying to figure out and predict whether or not there's going to be an outage based on the traffic and the metrics and the spikes and the logs and the exceptions and everything else, right? So you really have the ability here at the 7 and 8 streaming box to really kind of do all the analysis that you want to do. And when you do that, one, write it back to Kafka, right? It's like, I can't say this enough. Every single time you write somewhere, make sure it's in Kafka too, because once it's in Kafka, then somebody else can read that analysis instantly, right? So you could have a consumer, if you want to use something like Redis, you can use a consumer that consumes the data from this topic that has all this analyzed data, push it into the Redis cache, let Redis do its pub sub, and then have all the WebSocket end users basically have a UI that's completely changing in real time within less than a second from 1, right? All the way through to 11, you're like under a second, right? And you can see in real time whatever calculations are happening, whether it's number of users or latency, whatever you're calculating, whatever you're analyzing. And then you want to put that in your data store too, obviously, right? Because you want to go and run different batch analytics, you want to do reporting, right? You want your data store to basically have that information as well. So it's important to kind of, I think, understand the difference between where the Kafka broker plays from the distributed replicated log perspective, and then where data warehouses play. And to me, data warehouse is really Hadoop or Cassandra, depending on what you're trying to do. And then at that point, right, it's in, now, if you rewind to the beginning of the talk, like, yay, our data's in Hadoop. Let me use Impala to do an SQL ANSI 92 compliant query. No probs. Right? Or, oh, it's in Cassandra. Cool. Let me do a Solr search against that. Right? You just pop in DSE and like, boom. All the data in Cassandra is indexed in Solr, and you can go and grep. Right? So like if you use Splunk and you don't want to use Splunk anymore, implement an architecture like this. Put all your data in Kafka, have all the log data in Kafka, run it into Cassandra, use DSE, and then boom. Now all of a sudden all your log data is now searchable in Solr. Right? And this is This is becoming much easier stuff, right? I mean, in the grand scheme of things, it's hard, but from a software engineering perspective and the stuff that we do every day, it's gotten way easier, right? I mean, this is the kind of stuff that everybody is doing now, which is awesome. All right, so that's kind of all I had. I don't know if anyone has any questions. I guess hit me up for the next 9 minutes or until I get kicked off stage. And then I'll be around for a little bit after if you want to talk. That's cool too. Thanks. All right, so question?
Yeah, a question about, you mentioned a couple of mirror maker applications.
Yep.
And one of the ones that we were looking at did not have the ability to replicate to or mirror to like different topics.
Yeah. Welcome. Yeah, cool. So the question was different mirror maker implementations and being able to mirror to a different topic. Yeah, so there's a lot of different cruft in the Apache Project Mirror Maker, right? It's a good system for doing the one thing that it was built for. As you start to try to have it do different things, it's very difficult. We actually wrote an open source Mirror Maker. So if you go to github.com/stealthly, STEALTHY/go_Kafka_client, or just go to Google and just type in, go Kafka Mirror Maker, or just ask me later, whatever, anyway. So you can use that Mirror Maker, and that Mirror Maker has all sorts of bells and whistles you can prefix the topic, right? So let's say you have 3 data centers, data center A, data center B, and data center C is your aggregate, right? You don't have to have the topic names be different, so when it mirrors up to the aggregate, you've got 2 topics, right? How do you negotiate that, right? I have my Apple topic and my Apple topic, and now I'm trying to push it into the same. Maybe you want to have DC apples, right? And you want to separate that from a topic perspective. If you use something like Avro, you really actually don't have to do that technically, right? You can put that metadata information inside of the message. However, that's not always the best way to do it. And yes, sometimes you actually want to use topics to organize that, and we do that all the time, every day, 6 days from Sunday, continuously. And that's why we actually wrote a new Mirror Maker. It wasn't just about, oh yeah, let's just write this and go. It was more about we actually need this Mirror Maker to do stuff that we can't do with the Apache project. So yeah, I actually don't know of any other Mirror Makers besides ours and the Apache project one.
Can you say again the keywords?
Yeah, just type in Go, G-O, Kafka, Mirror Maker. Should come up. If not, then catch me after. Question? Yep. Yep. Mm-hmm. Yep. Yeah, so the question is for a company who's starting out that doesn't have RabbitMQ or Kafka, but maybe has something like IBM MQ series or something else, what's the recommendation? Really, the recommendation is, I would say, look at all the use cases that you're using the queuing system for, and see if there's anything that Kafka can't do, essentially. Right now, there's no out-of-the-box transactions, right? There's no idempotence. So if you are looking for your queue to do things like idempotence or transactions, you're going to have to build a lot of software to be able to do that. And whether or not that's worth it is a business decision, right? Do we spend the engineering resources to do this or not? And I've seen some people keep parts of their queuing systems, right, just because of things like that. And I've seen other people just say, we're completely getting rid of this, and we'll just take the R&D hit, and we'll just go build this one component that's not there. We'll just go build around it, right? It's not that big of a deal to build whatever was missing. And a lot of folks have done that, right? They've either had proprietary queuing systems or using some other large organization's queuing system. And the reasons that you do it is it's not only that it's just open source, right? It's also that you have a huge community of people using it, and it scales to really no other system. It's kind of cool. Yeah. It's hard for me to say what use cases you could have, but you know what? Honestly, there's use cases. If you don't want to implement JVM, can't use Kafka, right? You got to use Rabbit. What happens if there's a problem and you have to go fix it? Do you have any Erlang developers? If not, you might as well get a proprietary system, right? But if you've got Scala and Java developers, there's a whole lot more of those and a big community around it. So, there's a lot of things that you have to kind of weigh. And to me, that's not just a Rabbit Kafka thing. That's just more of a, how do I know which open source project to use, right? Who are the community behind it? How many different organizations are actually working in it? Now, Kafka, over the last couple years, went from, when I started with the project, it was the LinkedIn people and me. And like it grew. And it's cool because now you've got thousands of different companies, using it and hundreds of people contributing to it, right? Like literally hundreds of people contribute to it, and it's everyone, right? It's different answer over time. So again, it's hard to say which one to choose without specifics, but most likely I would end up saying Kafka, right? So yeah. Yep.
We have a microservices architecture with Java and some PHP stuff.
Cool.
How would we be able to incorporate something like this for apps that are on the PHP side?
Yeah. So the question is,
Other languages?
PHP.
Non-JVM.
Yep. So the question is, how do you do this in non-JVM languages? There. So the client page has there's so many clients. There's actually 3 JavaScript clients, right? So there's not enough room on this slide to even come close to putting all the different clients out there. There's a PHP one, there's a C one. So if you don't like the PHP one, the C one is awesome. The librd Kafka one is fantastic. Write a module, expose it,
You made a comment where you said if you're not on the JVM, you can't do this.
Oh, no, sorry. I was saying, I was thinking purely from the broker perspective. Like, let's say you had a requirement where you're at, you were.
JVM, NV. I don't want to use it.
Exactly, yeah. Yeah. Good.
So, from the perspective of the simple consumer
Yep.
Versus the new consumer, is there anything that the simple consumer can do that the new consumer cannot?
Nope, not that I'm aware of, honestly. The question is, is there anything the new consumer can do that the old simple consumer cannot? Other way around, right? Yeah. Not currently, not that I know of. Question? Yep. Go for it.
The context is about the so-called Kafka architecture, or where you are meant to perform analytics by paying ability to
Yep. Yep.
assume that you have.
I understand your question now. Yeah, I get your question. Yeah. I got it. Okay. Now I understand. All right, so the question is, how long does Kafka keep the data for? Right? All right, so there's 2. Yeah, what are the implications? Because it's a stream and it's just running and like, oh my God, what happens? Yep. All right, so there are 3 different ways that Kafka will delete data, okay? One is based on time, right? So you can set and just say, all right, after 4 days, don't care, right? Prune. You can say, after 20 gigabytes, don't care, prune, right? Or you can use what's called compaction. There's an out-of-the-box compaction. It's not hard to write your own. None of this is easy, but you can go in and write your own compaction as well. You'd have to change the source code, but people do this, right? It's open source. What compaction does is it basically, the out-of-the-box compaction, what it does is it looks at all the keys and basically gets rid of any messages that are older that have the same key, right? So if you're doing things like event sourcing, or you have some system where you only want to have the latest version, compaction is for you. Right? So there's a couple of different ways to handle that. Now, can Kafka store data forever? Sure. I don't know if that's a good idea, right? I usually recommend people to rethink why they're trying to do that and assess what solutions are there for them. Kafka's a streaming server, yeah.
I'm asking because usually this Kafka architecture,
Yeah.
system of the handle that.
Yeah.
Can we just propose it?
Oh, absolutely, yeah. So if you want to go back a year, you're better off taking the data wherever it's stored, loading it back into Kafka, and having the stream just sitting on that topic. A lot of people do that, right? Whether you pull it off of S3, we're talking about money at this point, right? It's like, I've got 48 terabytes of EBS versus it's not, whether it's AWS or whatever, it's not, you're talking about, different economics, right? And when you're at that scale, it's hundreds of thousands of dollars, right? So, and you have to think that way, right? Yeah, right. It's important. Yeah.
Yeah, so I might have missed the first part of it.
Yeah. Yeah, so the question is how best to use Kafka in AWS and how to deal and negotiate with things like the auto-scaling groups, and if a broker dies, how does it come back and all of that. Yeah, run all of that on Mesos. So install Mesos in AWS and then run, I'll give you a link. We can talk after too. Where is it? There. Yeah, so go to github.com/mesos/Kafka, and then this will basically let you run Kafka on Mesos. So once your Mesos cluster is deployed to AWS, then at that point, your auto-scaling is just the Mesos agents, the servers themselves. All the fault tolerances and running and starting and stopping and everything else, that's completely automated inside the software. Yeah. So that's even cooler. That's a whole separate talk. Come to Cassandra Summit next week, and I'm actually talking about that at Cassandra Summit next week with Docker and Mesos and all this stuff. But yeah, I mean, you actually could build very intelligent orchestrated microservices where you're building schedulers that are running and understand. I actually gave a talk about this at MesosCon too, if you want to check out the video, or we can talk after. You could actually build software that actually can orchestrate all the different microservices that are running. And those are both producers and consumers, right? And you build software, and I won't turn this into a Mesos talk, but yeah, you do that. Any other questions, or getting kicked off stage? Getting kicked off stage. Here comes the. All right, thank you, everybody. Appreciate it. We're going to be talking about developing real-time data pipelines with Apache Kafka. So quick show of hands, how many people know what Kafka is? Awesome. How many people have worked on and done development with Kafka? How many people are running Kafka in production? All right, cool, awesome. All right, so my name's Joe Stein. Nice to meet everyone. I'm CEO of a company called Elodina. We're a big data as a service platform company. Also Apache Kafka committer and PMC member. You can catch me on LinkedIn if you want to connect. I know some folks like to have the slides during the talk, so I already tweeted my slides. So if you want to go catch those on Twitter, I can go pull the slides down and what have you. All right, so today we're going to be talking about a whole bunch of different stuff, right? I really kind of want to drill into Kafka. This is not really going to be an introduction. It's going to be, we're going to get a little deep, right? Maybe like 45,000, 35,000 feet or so. So we're going to do a little overview just for folks who maybe aren't familiar with Kafka. And then we're going to talk about topics, partitions, and segments, data durability, replication, producers and consumers, talk a little about performance and kind of how that works, a little bit about different integrations, quick start, and then we're going to talk a little about operations. And that's going to basically kind of bleed into a couple of designs that we're going to go through and look at what are the type of systems that you could actually build with Kafka and how does that work and what does it look like from an architecture perspective. So we'll talk a little bit about distributed RPC and also a reference architecture for just run-of-the-mill storage and analytics, which a lot of folks are doing nowadays. All right, so Apache Kafka was first open sourced by LinkedIn in 2011. I joined the project pretty much right after it was incubated to Apache later on that year. I'm a paper fan. I don't know about other folks, but there's been a bunch of papers written about Kafka, from a technical perspective. So if that's something that interests you, go ahead and take a look. All right, so usually when folks are kind of getting into big data for the first time, right? Maybe there's some pilot project at your organization, but you go and say, all right, let me get a Hadoop cluster and let me go into some front-end facing service and let me get all the data and let me push it into Hadoop. And that's awesome and everyone's really excited and big wins and high fives and yay, now we've got all of our data in Hadoop and we're processing it. That's fantastic, right? And then someone comes along and says, okay, that project went so well, right, let's go ahead and take all of the data that we have in all of our other services, and let's push that into Hadoop so we can get the same benefit, right? So now you're at a point where you've got all your data, it's going into Hadoop, you're doing your batch analytics around it, maybe even doing some stream processing a little bit, and all is well. And then someone might come along and say, oh, this is so great. You've now integrated all of our front-end services going in Hadoop, but we have this entire real-time monitoring system that is already in place for our infrastructure, and we want data from all those services to go into our real-time monitoring system as well. So then you go in, and now you got to go and reintegrate to every single service, hook it in, move it over to the real-time monitoring system, and great. All right, that project went well, and now all of a sudden other people are getting in and say, oh, wait, we need that streaming data also, right? Let's take that streaming data, let's put it into the security system so we can do auditing and intrusion detection. Let's get into the data warehouse so we can have legacy systems be able to access it. And there are other consumer services that we want as well, right? You kind of get into this like n-squared problem of very difficult ETL integration. And that's really where Kafka comes in, right? Kafka is all about decoupling data pipelines, right? It looks like a messaging system, and it has messaging features, bless you. But at the end of the day, it's a distributed replicated log, and we'll talk a little bit about that. And if anyone has questions while we're going, ask. If I don't have the answer immediately, I may be talking it later. So if there's something that you're interested in, this could be interactive, if you like, all right? All right, so Kafka decouples the data pipelines, right? It basically separates producers and consumers. So people who are producing data and people who are consuming data can basically go through one single source. So instead of having an n-squared problem, you basically take that integration into a problem of one, right? And it's not a messaging system, right? It is a distributed replicated log, and it's very important to understand the difference, right? And we're gonna kind of talk as we go through and go about what is Kafka and how does it work. Hopefully you'll start to kind of understand what the differences are. Right, so when you're working with distributed replicated log, right, your producers can be consumers too, right? It's not just write data and then somewhere else down the line someone reads data, right? It's a very interactive process where if I'm a producer, I can be taking data, writing it in XML. There could be some other consumer that's taking that XML, converting it into Avro, another consumer that's taking that Avro data, running an analysis on it. And of course, obviously, at each step, there's a producer going back into Kafka, right? You can kind of have to think of this replicated log, right? So produce data into Kafka, push in XML. Some consumer reads the XML, turns it into Avro. Another consumer reads the Avro, does an analysis on it, produces it back to data, back to Kafka. Another consumer takes that Avro, puts it back to the original XML with the response, and then the original producer could actually get back that data in the XML format. Right? And that's what we're talking about when we're talking about decoupling data pipelines. It's not just the interconnected systems, right? And this is very important, right? It's not just the interconnected systems, it's also the transformations and the analysis that goes between these different data pipelines, right? So if I can only speak, message format A, well, there's no reason for me to not just always be producing and consuming from Kafka under the, message format A structure. Other consumers and producers can handle the transformation for the downstream systems. So you don't have to worry about where to put the transformations and how do you not just connect these systems, but how do you actually get them to talk in the same format? Very powerful feature. And it does this in real time, right? So you can throw as much data as you have at Kafka, and you're going to basically still be running as fast as your network, right? So it's quite performant. All right, so let's kind of start to dive down a little bit, right? So within Kafka, we have this concept of topics. Topics is really nothing more than a logical grouping of partitions, right? And a partition is essentially, think of a partition as a log file. Well, really a directory of log files, because that's really all it is, right? The partition is a way to organize your log files, and a topic is a kind of a virtual structure that allows you to group these log files together. And when you write to a partition, you're always writing and appending to the end of the log, right? So every single write appends to the end of the log. And Kafka guarantees ordering within a partition, so every single write that a producer has is guaranteed to actually be in sequence for when you actually wrote it on a partition by partition basis. Underneath partitions, there's something called log segments. This is sort of kind of important to know depending on what you're trying to do, especially when you're configuring the system and you may look in a directory and see 30 different log files and wondering, what is that? Ultimately, the partitions get rolled in log files, and those log files are something we call segments. And so you could have 6 or 7 different log files. That is a partition. And the view of that from Kafka's perspective is from oldest to newest, and data that is old can get pruned off at the end from the log perspective, the actual file perspective. Or if you're doing something like compaction in a more ingenious kind of way. All right, so when I think about kind of the distributed replicated log of Kafka, this is kind of what's in my brain. So you kind of have this log in the middle, right? There's your partition. Everything from the partitions perspective, right, it's a stream, and that stream of data is organized by what we call an offset. And an offset is really nothing more than an incrementing number, okay? Just literally just an atomic incrementing number. So as every single piece of data comes in, the next message just essentially gets the next number. In a traditional messaging system, messages will get pushed to consumers, right? And there's maybe some transaction around that. But in Kafka, that's not how it works, right? Producers push data to Kafka, and we'll talk about that in a little